Cool. All right. So I'm going to talk about the first of these classroom activities so that we can get some kind of feel for what you can actually do with something like Teachable Machine. So, you can see in Teachable Machine, you can go in there and you can train it, which is kind of fun. It's really interesting for students to do that. But there's a bit more to it. How can we sort of think about literacies in understanding AI rather than just sort of having a play? So the context here is having a think about what's called algorithmic bias, which is where you get unfair or discriminatory outcomes. And that often reflects or it sort of reinforces the biases that are already there, which tend to be in the data that goes in. So, the world is full of data. We train a system on it, but that data has all of the biases that went into it in the first place. And that's the real challenge that we face. So how do we help students to engage with that and understand it? So there's a really nice set of resources from MIT, Massachusetts Institute of Technology, their Media Lab. They've got an ethics curriculum for middle school students, which I took this activity from. It's about supervised machine learning and algorithmic bias, and it uses cats and dogs. Lots of machine learning examples use cats and dogs because I guess people understand them, but also there's a huge range of dogs and there's a huge range of cats. So the data is interestingly complex. So in this activity, students are asked to build a cat-dog classifier using Teachable Machine, but they're unknowingly given a biased data set deliberately. And the idea is that students can explore why that's a biased data set, and then they can improve the data set and they can see the consequences of that. So it's a really interesting, I think, example to do that's very easy. It can be quite fun for younger students, but it's got a really serious understanding at the bottom of it. Now, here are the training sets. You can see there's some pictures of cats and there's some pictures of dogs. So what do you notice about these two data sets? How do you respond to those as being a set of data to train a machine learning algorithm? What are your thoughts? You can either put your mic on or you can pop it in the chat. There's twice as many cats. Absolutely. There's a lot more cats than there are dogs. Is there anything else that you kind of notice about those data sets? Some dogs look like cats. Absolutely. Yeah. Now, that's an interesting one, isn't it? Like, if you look at those, I mean, even if I hadn't put them in cats and dogs, maybe I shouldn't have done actually, it would be more interesting. Would you have easily recognized that they were all either cats or dogs? Are there any there that you don't know whether they're cats or dogs? Dog 3. Okay.
3 and 5, yeah.
Do you think they're a bit cat-like?
Yeah.
Okay. The one about background, that's interesting too. So of course that the difference in the way that you present data, of course, is another layer of complexity. So that's a good point to make. Thank you for that. Okay, so there's too many, well, not too many cats. There's more cats than dogs. How diverse do you think those two data sets are? In terms of like the range of different sorts of cats or dogs?
Dog one seems to be a very narrow range.
Okay. So there's a couple of things going on here in a way, isn't there? There's the how many samples you have, and then there's also how diverse those representations are. Yeah, most of the dogs appear middle size. That's a good point to make. So we've got to, you might say, well, this data set may be a bit suspect, and that's the whole point. Yeah, that's a good point about their age as well. Yeah, like is the system given enough data to recognize dogs, puppies, cats, kittens? And yeah, that's a good point too. So what happens is that the students are given this data set. Now, you can do it with digital pictures, which I did for my example, which is a little bit boring, or the kids can hold things up to the camera, which is more fun actually, because it's kind of if you're holding things up to the camera, it makes it harder for the AI system as well than if they're kind of very clear digital pictures. So what we've basically got here is 7 image samples of dogs going in, 15 image samples of cats. Teachable machine can have lots of different classes, so we could have had, mice and monkeys or whatever. In this case, it's just the 2. And then we train the model, and then we can use that model. So the first step is the students put the data set into Teachable Machine, whether it's using digital pictures or whether it's using printouts. The MIT document, basically, you can print it out, and then the kids can cut out the pictures and hold them up to the camera, which they might find more engaging than just, uploading some digital images. And this is the test data set. So by doing this, students begin to understand how machine learning works. You've got the training data set, which you feed into the algorithm, and then you get a model, and the model thinks it's supposed to be able to differentiate between the things you've given it, because you've told it, okay, these are cats, these are dogs, work out the difference for yourself. And then we give it a test data set of other cats and dogs and say, is this a cat? Is this a dog? Okay. So any thoughts about the test data set?
Some real marginal ones there that could be either.
Yes. So it's quite, in that sense, it's quite a good test data set because it's trying to kind of push the boundaries of the machine learning algorithm by giving it types of cats and dogs that aren't, necessarily very, very similar to the ones it's already seen. So we give it the test data, and then we can compare each one. So you can see on the right-hand side, I've trained the model. It takes no skill whatsoever to train the model. You just click train the model. And then you give it something to compare. So I upload each image in turn, or you can just show it on the camera and say, is this a cat or a dog? And it tries to decide by percentage of how sure it is whether it's a cat or a dog. You can see in this example that it was 78% sure that was a dog, but it was also 20% it could be a cat. So of course it's using its data to make those decisions. What's really interesting about this example, and I'm sure you kind of know what's going to happen, is that it's a deliberately skewed data set, and so the students who play this game, as it were, understand that the classifier is biased. The classifier is biased towards cats, and that becomes obvious on some of the edge cases. So for example, this one here, yes, it's a dog, but it was only 68% sure that it was a dog. This is the most interesting one. It thinks that's a cat. 96% sure that's a cat, but it's not. So, this is where you can kind of engage with students about the sorts of questions that we already have just now. So, when you do it with students, you don't discuss whether it's a biased data set to start with. You just give them the data set and they go through the activity, and then you can go back and revisit it and have those discussions around, well, what do we mean by bias, and what's wrong with these data sets? Why doesn't the classifier work? So it can lead to interesting discussions, we hope. And then the next step is to give what they call the recurating data set. So you just add some more cats and you add some more dogs. Any thoughts about this data set? Any observations at all?
It's still not typical, really. On the dogs in particular are not your average dog, if you like.
Okay, yeah. I mean, I guess I suppose the reason why these are really interesting data sets to use, cats and dogs, that cats and dogs are incredibly diverse, aren't they? Which kind of suggests that you need a lot of different types of training data to be accurate. And one other thing that when I looked at this the first time, I thought, yeah. So just looking at the chat, yeah, same number of examples. That's an interesting one, isn't it? Because you've kind of got you might think, well, shouldn't you balance up the number of dogs with the number of cats? But actually, the more you put in on either side, the better, because it gets better at cats and it gets better at dogs. So the fact that we're not necessarily sort of balancing up the numbers isn't necessarily a showstopper, because the more information we give it, the better. Looking at some of those other ones in the chat, there's quite a lot of different observations you've made about the limitations of the data set, in lots of different ways, like poses and sizes and all sorts of things. So, these are all very interesting points, because all of these, hopefully, the kinds of discussions you have with students, so they can pick up all of those different things about how do you get a data set that isn't biased. You have to think about so many things and such a quantity if you want to get an accurate classifier. So I think those are the kinds of learnings that you want to have coming out of this activity. This particular data set, of course, is small enough for students not to spend hours working with it, but it's been designed so it kind of illustrates the point it's trying to bring over. So the question here is, what was the impact of the updated data set? I'm pretty obvious, but I'll ask it nonetheless. Sorry, I didn't mean to click that on. I mean, I've highlighted the relevant numbers. What do you see? Yep, it got better. It definitely got better in knowing that was a dog, right? That was the key. That was the worst piece of classification that it did the first time round. And of course, if students are doing this, they might not get the same numbers as me, because I did it using the original images, and you probably get the same thing if you did that. But if you're holding up pictures, you might get all kinds of variations here. The other thing, and it became more sure about this one, this one's absolutely fascinating to me. It became less sure that that was a cat, because that, as it got more dog samples, it started sort of thinking, oh, actually, that looks a bit dog-like. So I thought that was another really interesting aspect of the data. So, that the suggestion there, and some of you have been kind of suggesting, like, well, don't we need more variation? We're now undermining its ability to be sure about cats, because now we've given it more dogs, but maybe we needed to give it more cats of a particular type in order for it to be more accurate. So yeah, I think that's a really kind of interesting example. So that's my first example. It's a very simple machine learning activity you can do with students. You can do it with young students, because the tool doesn't have age limits. It's not doing anything dodgy with their data. Their data isn't not there. It's just cats and dogs. But it gives an opportunity to explore those AI literacies around bias and how machine learning works, and the processes of creating something with an AI tool, all done in a fairly simple and straightforward way. Cool. Okay, so what I want to do now is to move on to my second example, where we are looking at generative AI. So most of the generative AI tools have a sort of 13 plus age limit on it. And of course, schools and education authorities and whatever might have other regulations as well. But taking that as our baseline, I wanted to look at something that you'd probably do with older students. So just before we go any further, what do we mean by generative AI? This is from the New Zealand government, and talks about what generative AI is. So generating text or images that similar to what humans do. They match user prompts to patterns in training data and use probability. This is where generative AI is different to traditional machine learning, in the sense that traditional machine learning is typically supervised, which means that you give the machine, like we did with the previous example, all of this stuff, and then it, rather than filling in the blanks, it's just trying to recognize the next thing and putting it in the box that you've provided. Generative AI is very different because it just has algorithms that, as it says, fill in the blanks. The next thing that they do. So, for example, a chatbot, the next word is just what it thinks is the most likely probable word that will come next based on the huge amounts of training data it's seen in the past. The reason that they're non-deterministic, that is, you never get the same thing twice, is that there are kind of subtle weightings that are going on, and each of the neurons in the system has many, 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 many layers, and in each one of those layers you might get slightly different things happening. So that's why you can ask a chatbot the same thing 2 different times, and it'll come up with 2 quite different but equally tedious answers. As I'm sure you're aware, Gen AI is being used everywhere. Lots and lots of people are using it. You may be familiar with There's an AI for that website, which has an unbelievable number of AI tools on it. But the key message from the government here in New Zealand is we need to learn about it, understand it, and work through how to use it safely. So I guess that's my starting point. So Gen AI is out there, it's being used. Older students need to be given the opportunity to engage with it, again, through the lens of AI literacy and in the same kind of space as the previous example. So this just a reminder, really. So this is from the OpenAI terms of use. They specifically talk about ChatGPT, DALL-E, and so on as being 13 years old. Now, this comes from, particular countries in Europe, but the Ministry of Education here follows the same thing. So they kind of just copy and paste this onto their own website that you need to be 13 to use these tools. So, if you're going to do this with students, it also says you must have your parent or legal guardian's permission to use the services, which is an interesting one. I'm not going to go into this in detail, but I think Mila found this one originally. This is purely to make the point that in education, generative AI applications are already coming out of our ears. There's a huge number of applications in the education space that are using generative AI. So if that's the case, again, from an AI literacy perspective, students need to kind of understand what's going on in these tools rather than just using them. I mean, yes, use them, but we need to use them critically. And what I want to do is kind of revisit bias, but I want to revisit bias in the generative AI space. So I'm looking at the same literacies, but in a different context for different audiences. So perpetuating human biases within society, historical, social inequality. Bias can be found in the training data. So that's what we were seeing in the teachable machine, but there's also other sources of bias. It can also be in the way the algorithm is written, because the algorithm in generative AI is not as simplistic as is it a cat, is it a dog? It's a bit more complicated than that. So there can be bias in the way that works. And then, of course, that can lead to bias in whatever the algorithm produces, because when it says predictions, generative AI is kind of guessing what might come next, and those predictions can be biased. So this is why it's not just about the data. For older students, you can dig a bit deeper with generative AI. There are actually 3 types of bias. So we've got data bias, which we've kind of already seen in a sense, like we had a bias in our dog-cat sample. It can be the same for minority groups in society. There's the way that the algorithm works. And then there's the way the models are trained might then represent social bias. And that's where we get into some really deep ethical and social questions that are not too easy to answer, but are good discussion points for older students. Okay, so this is one of my favorite things that you can do with AI, because it doesn't seem to be improving in any way, which is what I call the trouble with beards. So I'm sure many of you have played around with image generation, because it's hugely entertaining, isn't it? And I kind of discovered by accident that the word designer, and it doesn't seem to matter which AI tool you use, a designer is a young white man with a beard. Just is. I'm sorry, that's the way it is. There's not much you can do about it. I generated these with Bing, mainly because when you do it with Bing, it gives you 4. Most of the other ones you'll ask it to do an image and it'll do 1, and then you do another one. Bing does them in groups of 4, and this is kind of what it does. It comes up with you know, white young men with beards. Another interesting one, the reason this one's called Man is to Computer Programmer as Woman is to Homemaker is that it's actually the title of the article I cited at the bottom. And it's about algorithmic bias. So we've been talking about data bias before, like, okay, if the training data that says that designers are young white men with beards, that's what the thing's going to come out with. But there's another layer to it, which is the way that the algorithms work. I'm not going to attempt to explain exactly what this article is talking about, but it talks about representing text as vectors in the way that these algorithms actually work. And they use a technique called word embeddings, and word embeddings have been shown to show bias. So there's bias in the data, but there's also bias in the way the algorithms actually deal with that data that kind of compounds that problem. So here's my suggested learning activity based on these clear issues that we face in data and algorithmic and social bias. So get students to use a suitable AI image tool. Some of them are free, some of them are not, but I mean, they can kind of choose whatever ones they want to use. So DALL-E 2 currently is free, Bing Image Creator is free, Canva has a free version. There are plenty of others where you can generate AI images, and ask for a picture of a designer. It shouldn't say either, it should say ask AI for a picture of a designer, and then just discuss the results. And then go into some other generations that represent different demographics. So, if you try to specifically prompt for gender, or specifically prompt for ethnicity, or specifically prompt for types of designer. So if I said kitchen designer, what do you think that would that be a young white man with a beard, do you think? It might well be a woman. I mean, the thing about this is I can say, oh, go and try this and this is what will happen. And of course, but I can't predict it because generative AI might well come up with, a completely different thing to a young white man with a beard. But there's definitely there's certainly a trend across multiple tests if you do these things where you can kind of see it's quite determined. I did a thing a while ago for my software course, and I had a description of all the attendees at an analysis meeting that came from a textbook I'd written years ago, and I just put them in and said, make a picture of these people, and they were mostly young white men with beards. So I tried to stop it doing this, and I kept telling it, look, I don't want all of these men with beards, but it wouldn't stop. It just insisted. I'm sorry that these people, they are men with beards, and in the end I sort of gave up. So it can be a really interesting experiment to try and see what do you have to do to get the pictures that you want. Oh, look, is that a young white man with a beard? Like, excellent. No, that's an interior designer. Could you try kitchen, maybe? Sounds like my ginger.
That mine was just a designer. That's just that
Okay,
happened to be just a designer.
right.
Are there any kitchen ones? The kitchen one is male man with a beard too. For me,
Oh,
I'll share
no,
that.
that's
Oh no.
I put
excellent.
interior designer and got only one of the pictures with a person in it.
Oh, yeah. Yeah, you just got an interior design, kind of.
Yeah.
But the designer is actually a young guy with a beard, right?
Yes.
Yeah, yeah. It's an interesting thing to do with students, I think, because you know, it makes it clear that there's bias occurring, and then you have to kind of think about, well, where does that bias come from, and so on and so forth. So it's a fun activity, but it's also got a dark side that leads to some really useful discussions, I think. And then, sorry,
I have
go
to
on.
say that it actually looks like that kitchen designer there looks like the kitchen designer that I was on our holiday kind of Christmas table. My partner's brother is a kitchen designer, and
Ah,
yeah, with a beard. Yeah, so
right, of course.
yeah,
Yeah,
yeah.
yeah. Yeah, not that there's anything wrong with beards, obviously, or indeed white men. Just saying. Well, actually, I don't. Yeah, yeah, anyway, moving on. So let's have a look. So yeah, so in this sort of class, so I've got a few ideas about, follow-up discussion points. So, thinking about, and this is actually goes into quite tricky areas, like data sets might be unrepresentative of society. So they might over or underrepresent certain identities that don't really reflect society. The other thing, though, is that your data sets might be accurate, but they might represent an unjust society. So, it might not be telling you something that isn't true, but what is true isn't good. So that's kind of where these kind of ethical discussions come in. And there's an article by McKinsey, which I've cited there, which I found quite interesting, which asks questions about, what is fair? What's it fair to do? What are we supposed to be looking for when we're looking at these systems? So if you search for CEO images, what's a fair percentage? Is it the actual percentage of women CEOs? Is it something more aspirational? If it's more aspirational, like, so if you say, okay, it should be half and half, well, who decides? Or who decides what the percentage should be and why? What's the grounds for that? So you have really interesting ethical discussions with students around, as soon as you go away from, for example, let's assume that a data set reflects society. Is it, what gives you the right to decide that you particularly can decide that it should be X? Someone else might think that it's supposed to be Y. These are the kinds of interesting discussions that I think, enable students to engage with concepts of AI literacy in a useful way. One of the other issues is, how many fairness metrics can you use together? Because it's not just about male and female representation of role. There are so many other layers to what you might want to be representing fairly in society, in terms of culture, body shape, politics, appearance, so many things, right? And unfortunately, it's almost impossible to balance all these things. So again, arbitrary decisions. CEO, young guy with 5 o'clock shadow, of course, because they work so hard, don't they? CEOs, much harder than the rest of us, haven't got time to shave. Maybe that's why they've all got beards. They're just working much too hard. Yeah, and thresholds, like when, what's the threshold for making decisions about these things? So I'm not saying there's any answers to these, but AI literacy is about critically engaging with the problems and understanding that we can't just take, what AI generates, as is, and assume everything is fine. I think those are the kinds of messages that we want to address. Okay, so I've got one final activity that I'd like to talk about as being, I think, in a scar, that might be an interesting one to do with students. Now, I didn't want to say what age I felt was appropriate for this, because I'm not sure it's an age thing, but students who are mature enough or sensible enough to discuss life and death decisions without it turning into well, I don't know, a train wreck, which this is from the framework. Apply ethical frameworks or moral principles to evaluate the impact of AI on individuals and society, determining what is just, fair, and beneficial. And so this appeared as one of the ones I showed earlier, but I think this is the key one that applies to this one. So thinking about ethical frameworks and moral principles in artificial intelligence. I'm going to use play another very short video. This is pretty old. The Moral Machine's been around for ages, as have self-driving cars. I'll play this video first, and then I'll talk through a bit more.
Welcome to the Moral Machine, a platform for gathering a human perspective on moral decisions made by machine intelligence, such as self-driving cars. We show you moral dilemmas, where a driverless car must choose the lesser of two evils, such as killing 2 passengers or 5 pedestrians. As an outside observer, you judge which outcome you think is more acceptable. You can then see how your responses compare with other people. If you're feeling creative, you can also design your own scenarios for you and others to view, share, and discuss. Moral Machine is a project by the Scalable Cooperation Group at the MIT Media Lab. Help us learn how to make machines moral. Cool.
So yes, another great product from the MIT Media Lab. So as you can see, what you get to do with the moral machine is you get to make lots of life and death decisions about, is a self-driving car, the brakes have failed, what does the self-driving car do? And of course, one of the reasons that this is really important is that the self-driving car doesn't know what to do unless at some point someone has programmed that into its AI systems. And when you do this, I mean, it's fairly random, so you can't predict exactly which questions it'll ask you, but it tends to start with fairly obvious ones, like, I'd rather run over a cat than 5 people. Well, maybe, who knows? Depends on the cat. But they get harder and harder and more complicated. And it's based, some of you might be familiar with the trolley problem, which is the historical version of this, which is, there's a runaway trolley or train coming down a track, and there's a junction, and there are 5 people on one track and there's 1 person on the other, and the question is, if you've got control of the points, the only thing you can do is to change the points, would you change the points to kill the 1 person or the 5? And most people say, oh, I change the points to kill the 1 person. And then the second question is, okay, you're on the bridge and you can see this is happening, and you can't change the points, but you can. There's a person on the bridge, and if you throw the person off the bridge, the 1 person, you can save the 5. And that makes it much harder because people are much less willing to push someone to their death to save the 5 than they are to change the points, even though, really, strictly speaking, it's exactly the same thing. So the point about that trolley problem is that it raises really fundamental moral problems, and so does the moral machine, but it's in the context of artificial intelligence. So it's a really interesting thing for students to do. There's 3 different ways that people can engage with moral machine. They can either just judge the existing ones, that are in the system, or as you saw in the video, they can design their own new scenarios where they can kind of think about different factors that might come into play, and then other people can look at those, or you can browse the customized scenarios of others. Again, there's no right answer to this, and one of the reasons they do this system is like they just gather these responses and they can kind of report back what people will say, but it's not as if, oh, that, you got it right, you got it wrong. It is a moral decision, and those decisions are made based on a whole range of complex things. So yeah, the kinds of things that we're doing. I'm going to pass over to Mila in a moment, but just before I do, because I'm sort of done with my content, I just wanted to go back through my slide set to what I started with, which was the AI literacies that I mentioned briefly, just to kind of link back. So the sorts of things that we've been talking about tonight are, machine learning, understanding data, how we can interact with AI systems, the implications of data on training of models, ethical implications, particularly bias, and how we might mitigate the risks of AI systems. I hope we've kind of touched on all of those in one way or another. The level 2 is kind of the extra layer, I think, was, I'll just pick out a couple in terms of key terms of the way that models are trained, sources of data to train models. I think particularly the most important ones are more in the sort of the ethical space. How does bias occur? Examples of ethical issues, the risks of data in AI systems and applying ethical frameworks. So I'm just trying to sort of draw this back to you can do an activity and you can learn really interesting things, and you can also in the same process develop your AI literacy that you can then kind of reapply back to these kinds of questions that we're supposed to be engaging with, checking outputs, understanding cultural bias, those kinds of things. So thank you for your attention through all of that. I've just got a couple of things at the end that I'm going to pass back to Mila to just talk about, which is if anybody's interested in any of our amazing courses, I would studying at Academy X. I'll pass back to you, Mila. Do you want to
Thank you, Dave.
to the next slide?
Okay. I recognize many of the faces here, so most of you are actually our students already or have been. So just as a reminder that the applications are open. For example, there's the new Digital and Collaborative Learning postgrad starting in March. Either you or someone who you know who would like to jump in to this waka, then there's scholarships available. And if you have already done first part and want to continue on the second part, which I know some of you have just started or about to do also that, maybe there's someone else who wants to do that too. So Master of Contemporary Education, then that part 2 and 3 start in July. If you want to do part-time, full-time would be next January. And of course we do other things. So that's just an image from our website. So micro-credentials and yeah, other master's programs too, of course. All of them in one way or another. Yeah, we talk about AI literacy at Academy EX for sure. And I think the next slide that I pop there was just about the scholarships. Since we did check today, Dave, that there are, wasn't that so? Scholarships still available?
Yes, so I checked today. So with the scholarships, if anybody is thinking of applying for things, so you apply for the scholarship when you apply for the program, and then we have a scholarship panel next month where we go through all of the applications and actually award the scholarships. So the scholarship awards are made later. So it's not first come, first serve. It's basically give everybody a chance to apply, and then we go through and process those applications based on how many we have compared to how many scholarships are available.
Looks like there's definitely an opportunity still to get that. So an impact scholarship, impact is the one that I'd say that all of you who are somehow related to education, like your studies are going to have an impact. So then the impact scholarship that takes 50% off from what you have to pay, so that would be worthwhile. Of course, there's other scholarships too, and we're here with Dave. We can stay here for a bit to chat if there's any questions.
So I will. I'll close off with the karakia now. But as Mila says, if anybody wants to stay behind and sort of have any conversations about anything, we'll be staying online. So I'll just wrap it up formally with our karakia for those of you who need to head off, and just like to say thanks so much for coming tonight. I hope it was interesting. Thanks for your interactions in the chat. There's some really cool stuff in there, including that Chat GPT explaining what it should be doing even when it doesn't. So yeah, thank you for that. Okay, I'll close with our final karakia. Ka whakearea te tapu, kia wate aitiara, kia tura ki whakata ai, kia tura ki whakata ai, homie, huie, tai kia. Thanks everybody, ka kite anō.